एक मिनट.
Hello everyone. We'll start at 8:15. We just want every registered person to attend the workshop. So let's just wait for a while.
We'll wait for a couple more minutes. Like there are some people yet to join, so we'll start at around 8:15. Uh, yeah, so I think we can start.
Yeah, so hello everyone. Welcome to the Python Workshop 2025. I'm Sneha Mani. I'm the events manager along with Gokul. He is also the events manager of AZeotropy 2526. Today we have a Python workshop which will be a 2 hours quick session about the introduction to Python and some of its libraries. We have with us the instructor as Malladev Bhattacharya, who is a doctoral researcher at the Department of Chemical Engineering at Indian Institute of Technology, Bombay. He specializes in computational fluid dynamics, numerical simulation, and mathematical modeling of multiple phase flow using tools such as Python and OpenFOAM. He has hands-on experience in developing Python scripts for engineering analysis and simulation workflows. And he's a very practical and theoretical person who would explain, who would take you to the from the scratch to the advanced level of the Python. So let's deep dive into the Python workshop. Over to you, Maladev, sir.
Hello, am I audible?
Yes, you are.
Yeah, thank you for the kind introduction and also the opportunity. So, yeah, as Neha said, today we will discuss a bit about Python, what it is and what can we do with it. And hopefully I'll give you a head start as to where to look for if you are interested in more details, right? And I don't think we will have enough time to cover everything that Python has to offer, which is not possible, right? You will see that YouTube, if you go to YouTube, you will have lectures, multiple lectures, right? 80 lectures in a single Python course, which is not possible to cover in 2 hours. But I'll try my best to give you flavor of some of the most important things in Python, and also some sneak peek into some things that we couldn't cover, but you can cover if you want to yourself, right? So one thing is that if you find if you are having some difficulty to understand any of the concepts that I'm talking about, feel free to interrupt me. Otherwise, it will be nice if you could keep your mics muted, right? Or else it creates an unnecessary disturbance. And for bandwidth reasons, let us also keep the uh, cameras of video cameras off, right? So what I'll do is that I'll share my screen. I hope I have access to that. Yeah, everybody can see my screen, right? Hello.
Yes, yes.
Yeah, fine. All right, so you can see the slide, right?
Yes, we can see your slides.
Yeah, fine, thanks. Yes, so yes, so today we'll discuss about Python. And what we from our school days, what we mostly know is that there are two types of languages broadly. One is compiled, which where the we you write some code and there is a compiler that will compile the language for you into an executable script. In Windows it is typically .exe file, right? And what you can do is that then you can execute the exe file and you will get whatever result you want, right? That is something which C++ or Fortran does. They are compiled languages and they are very fast. But the one of the cons of that is it is intricate and it is very difficult to learn, right? It requires a lot of patience and you need to be a lot more explicit with the compiler to get things done properly, right? So instead of doing C++, many people have made the switch to Python. Mostly people who are not so interested in doing being so explicit with the hardware or the computer that they are working with, right? So they don't want to be explicit. They want to be they want to have a simple conversation with the computer when they are coding. So that is why Python came about. So one thing to note, and which is pretty funny, is that Python is an interpreted language and the interpreter is written in C, right? So it at the end things are happening because someone wrote something in C and made it easier, made an easier interaction medium with the coders, right? So Python is an interpreted language, which means that it executes your code line by line. So if you have a 10,000 lines code, it will start execution from the first line and it will keep executing line by line, and if it reaches some error it will just stop execution and say, oh, you see I have some error, please look into it, right? Which also means it is dynamic and it is very slow in execution. So Python is typically, my experience says, can be even 1,000 times slower than C++ when you are, if we are talking about scientific computing, right? It can be 1,000 times slower, right? But what the good part is that it is pretty user friendly. And how user friendly, I'll show you. So let me just open a terminal. So I will not go about installation of Python and everything, right? This is pretty basic. You can just go to their website, download the exe file, it will install. And the software that I'm using for the coding part, which are also known as IDE, Integrated Development Environment, that is VS Code. And I strongly suggest, if you are serious about coding, please use one ID like VS Code or some other, whatever you prefer. But I find VS Code pretty useful. So what I'll do is that I'll just open a Python terminal. As you can see that I can write anything in this terminal. So anything I write here has to be a Python code. Even I can write 6 plus 2 and it will give me 8. If I were to do this same thing in C++, what I would have to do is that I have to write 10 lines of code, include a lot of header files, include something known as namespace and all that thing to just to go to 6 plus 2 equal to 8. Right? So I'm not telling that C++ is not important. If you are really serious about developing something, you should first look into C++, then come to Python. But if you are not so serious, you are more interested in the physics part or the application part, then Python will get your job done, right? And I'll show you some techniques by which you can also make Python work very fast. So that was the introduction that I had for Python as a language. And that was barely an introduction, right? So if you go to any book on Python, they will spend one chapter on introducing you to the language. But what I'll quickly go through is the basics part if you start writing Python code. And secondly, I always find Jupyter notebooks to be a nice place to start writing in Python. You can also do this in Google Colab, for which you don't need any installation in your machine. It's purely browser based. Google Colab is something that you should also look at. But Jupyter is pretty nice because you can write things to make notes. You can also run codes, Python codes in small cells like this. So these cells will only run and they will give you their own output, right? So what I have been told is that the audience has from first year undergrads to fourth year undergrads, which means that maybe fourth year undergrads might find the first part of this workshop pretty boring, right? Because I'll just go through some data types and stuff. And first years may also find it boring because I think CBSE class 12 now covers Python. But what I'll do is that I'll take 5-10 minutes to just go through the basics quickly, very quickly. I'll assume that you all already know this stuff. I'm just brushing up so that we can take the conversation further, right? So yes, so data types are something that we need to worry about when we start coding in any language, right? And Python typically has 4 primitive data types, which we will be mostly concerned with as engineers. So first is integer. So Python gives you a function where you, which is called type. If you put say type and pass any variable to it, it will tell you what type is it. So int typically means integer, because I have already initialized this variable as an integer. Similarly, if you initialize it as a float and pass it to this type function, it will give you a float. Now, one thing that is very important and sometimes we encounter in while coding is that we have a floating point number and we want to forcefully convert it into integer number, right? So floating point numbers typically have a decimal and some other digits after this decimal point. So integers don't have decimal, right? So if you forcefully convert a floating point number to an integer, what it will do is that it will just delete whatever was just after the decimal and give you this number. So let us see that in action. So what I just did is that I passed this float num, whatever variable I have declared, which is 5.42, to this integer function or class. Let's not worry about class, just let us say that this is an function, right? So in integer function, if I add a floating point number, it will forcefully delete everything after the decimal point and give you integer. So this process is also known as typecasting. Now floats typically also have something known as precision, which will be very useful if you are into something like simulation of physical systems and stuff. So then precision becomes very important. So precision typically talks about how many digits can you write after a decimal point. So if I can write 10 digits, it means the precision is 10. If I can write 16 digits, the precision will be 16. So typically floats have a precision. Floats are also known as double precision numbers because they have 16 digits after the decimal point. If you want more, you can also have that in Python, and that is something that is uh, it does not come in the purview of basics, right? So then let's not discuss about precision. Precision is something that deserves a separate lecture on. But if you want to have a simple idea of precision, how many numbers can your computer represent after decimal? So typically it is 16 in any of the computers that we work. So one more data type that is pretty important and probably most primitive is Boolean, right? Which can take only two values, either true or false. And this sort of corresponds to the machine language for 1 and 0. So 1 means on state, 0 means 0 state, right? So everything that you see in your computer is a combination of 1 and 0 or true and false. So another data type that is very useful, and most likely if you sit for placement interviews and stuff and also placement tests, they will have one coding question which will use this data type, which is known as string. So typically strings are basically array of characters. So what I can do is that I can write something. These could also be numbers, but they have to be inside single quotes or double quotes. So either you write it this way or you write it this way, right? And let us go back to Azeotropy, and if I run, then it will tell me that the type of this variable is str, which is the short of string. Now string has very interesting functions, but before that let me see one thing if it works. Yeah, so what it did is that it went to the sixth element of this character array, whatever I had. So AZeotr, which is the sixth element of this array, and it just printed R. So strings are basically combination of these characters. So this is something, it was a side note, you can play around with it later. But string already have some very fun functions. One of them is capitalize. So if you say this string variable dot capitalize, it will just capitalize the first letter. Similarly, if you say that no, I want to capitalize all the letters, then you have to call this function which is known as upper. then it will convert the entire string to uppercase. Then few more functions are, if you want to find out at what index, like this is 0, so A is at 0, Z is at 1, E is at 2. Similarly, you can find out the index or the position of all these letters. If you just want to find out whether R is present and what is the position of the R, you can just run this and it will tell you 5. Right? So these are some fun string functions which come in pretty handy when you are working with complex workflows. And if you want to look more, the notebook has one link here, which is typically directs to a Python documentation. So one more thing is that I will share all these notebooks with you, right? So if you can follow me, because I am moving in a pretty fast pace, if you can follow me, it's fine. If not, you can also try these things out later, right? So I'll share all these things with you. Yes, one more important thing about any language is, if I want to print some data for the user to look at, how do I do that? So Jupyter typically, if you see, has been printing everything, whatever we are doing. But typically, if you write a script, which is anyway I suggest you do if your code is very complex, then you need to print out things so that the user can see. And the function here is pretty simple. It's called print. Just take any variable, pass it to print, and it will print it into the console. You can also combine them with strings and stuff, and you can also say how to end a line. So if you say end with quotes which don't contain anything, then it will just not go to a new line, but it will just put everything one after another. If I don't add this end, it will print in separate lines, right? So instead, if I put this, it will do this. If I do this, then it puts a comma, right? Anything you can do to separate out stuff. So in print statement, some things are very important, also known as escape sequence. So instead of, if you, let's say, want to write a string and you want to make a line break in between so that this part goes to the next line, you can add \n and it will push everything to the next line. Similarly, if you want to add a very long space, also known as tab instead of a small space, then you can add \t and it will add a big space so that things are shifted, right? Now the next part that is very important is obviously arithmetic operation, and this is really simple. So I will not spend much time on this. So I have two numbers, 13 and 4, and what I want to do, I want to add them up. Addition is pretty simple, subtraction is same, division is just divide, product is take you product, and one more very important stuff is modulo. So what it does is that from a division, whatever remainder was there, it will just return. So if you divide 13 by 4, the remainder will be 1. So that is why you get 1, right? One more very special thing is that the special type of division is known as integer division. So you see, when we did the division, 13 divided by 4 is 3.25. Now let's say you don't want to retain the decimal places after division. You just want to find out the quotient of this division. What you can use is the integer division, which is just double slash. So division, floating point division is just single slash, and integer division is double slash. So it will just return the quotient, right? Similarly, you can also do take powers. So to find a square of one number, you can just multiply it twice, or you could use the shorthand notation, which means num to the power 2, right? Or you can also do num1 to the power 2, then which means the first variable to the power the second variable. That is also possible. Anything is possible using this operations, right? So these were arithmetic operations, but the funny part is you can also do arithmetic operations on string. So what you can do is that you have, let's say I have three strings. It's called I love Python. And if I add them up, what it will do is that it will just give you a new string with all of them added together. It's clubbed together. So it will give you I love Python. But too bad, we also need spaces, right? So that it looks nice. So that is why what you can do, you can add spaces like this, which are just empty quotes with one space inside. And then you get I love Python, right? It's as simple as that. It shouldn't be very difficult for you to catch on. One important thing that you will probably use all the time in Python is importing modules, right? So some modules are already there in Python, which already come with Python when you install, and some modules are which people have developed, other people have developed, and you can also install that and then use that for your purpose, right? So one such module which is already there in Python is called math. So it gives you access to many math functions like sine, cos, tan, log, blah blah blah. So what I do is that I import the library math and I set an angle which is 30. Since I want math takes input in radians, 30, I cannot pass things in degree. What I should do is that I should convert them to radians by multiplying with pi by 180. And if I take the sine of that angle, it gives me 0.49999, which is pretty close to 0.5. So how close will it be to 0.5 is decided by how well I am representing pi, right? There is also a way to represent pi in a nicer fashion in Python, but we will get to that later, right? So these are some math modules that you can find. For more math functions, you should look here. So these were some of the very basics of Python, and this is common for most of the languages that you work with now. Fortran, C, blah blah. Anything will give you all this uh, opportunities, right? So what I would like you to do is that just go through the notebook once later, once you have it, and I also have provided some empty cells. What you can do is that you can start writing your own codes here and see if you can take help from the links and whatever I have written in the notebook. Right? So that was the basics part, and now we will move into some a bit more advanced stuff. So if you have any questions up until here, you can ask now. And if not, then someone just unmute and say no. That is also fine. All right. I saw I'll take
Yes, sir.
silence. Yeah.
No,
Someone is.
no doubt.
Okay.
Go on.
Thanks. Yeah. So let us move into the next part. So that was very basic and pretty boring. This might also be very
Sir,
boring for. Yeah. Yes.
I have a doubt, sir. In
Yeah.
import
Go on.
math, thus we can calculate differential and calculus in that.
So these are simple math functions, right? Cos, then let's say sine, tan, log, maybe tan, hyperbolic and stuff. If you want to do differential, uh, one thing is that you cannot take, so you write differentials as ddx, right? Those are continuous, operated on continuous function. That is not entirely possible in computer, because computer only understands things in a discrete form. So it's only 1001 but in this continuous function it will be infinite precision. So that is not possible even in computer. What you can do is that you can take help from some specific libraries designed for this, which I'll write the names here. Maybe you can look at. One of them is known as SymPy. They can uh, do all this continuous differentiation in Python. And if you are interested in numerical differentiation, you should look at NumPy. So NumPy we will discuss later, right? NumPy and also SciPy. So NumPy we will discuss later, but if you are looking at differentials and stuff, then you should look into SymPy. Understood?
Understood, sir. Thank you, sir.
Yeah. Thanks. So let us move ahead with the next part. The next part is again something we have come across in if you have done a bit of basic coding up until now, which is known as flow control. So in any language, they allow you to provide conditions, and based on that conditions you do something, right? That is possible in any language. And the most common or most let's say use statement in this area is the if else statement, and it is pretty easy to understand from the wording. So if some condition, if the condition is satisfied, you do something. There are also else if, so you can put multiple conditions here. If first one is not satisfied, go to the second one. If second one is not satisfied, go to the third one. So that is why you have else if, or in Python they call it elif. right? And at the end, if nothing works, then do something, which is known as else, right? So if else is the most used statement when it comes to branching in any scientific coding purposes, right? Even if you go to AI ML today, you will probably use a lot of if and else statements, right? So one thing, I will demonstrate the working of if and else with a very simple code where I give any random number here. Let's say we already know that this number is even because it ends with 6, right? So what we will do is that we will just check if this number is even or odd. So to do that, what you can use this is the modulo operator. So what we know is that the modulo operator gives you remainder from a division, and we know that any even number, if you divide it by 2, remainder should be 0, and if it is odd, remainder should be 1. So what you can write is that if num mod 2 equals 0. So equals is used to compare two entities to the left and right of this symbol to check if they are equal or not. So if you say num equals something, then it is assignment, which means you are assigning this value to num. But if you use 2 equals, it means that check whether the left hand side is equal to the right hand side or not. If it is equal, it will return true, or else it will return false, or you can think of it in terms of 1 or 0. If it is true, it will return 1, or else it will return 0. So you already know that if this should give that the number, whatever number we have, is even. So instead, what we could have also done is that we should then put some other number here and it will give you odd, right? You can also play around with this logic. What you can say, instead of equal to 1, you say 1 and you write here odd. That is also a perfectly fine logic. So branches can be have infinite, in this case it cannot have infinite permutations or combinations. So what you can do is that you can work with multiple branches with multiple conditions to arrive at the same result, right? So you see that there are already 2 ways to arrive at this. So this is the typical working of an if else condition. And what is even nicer is that you can also put another if else inside already one if. So what we do is that we have a nested or branched condition, that if this is true, then check this. If that is true, then do that. Then inside that also you can have multiple branches. So let us, I have just constructed a simple test case here. So I say that animal is one variable which has been assigned a boolean value of true, and type of the animal has been assigned a string which is cat, right? So if I see if animal is true, then you go inside and check if a type of animal is dog or not, right? If a animal type of animal is dog, then you say animal is dog. If not, it's just say print animal is dog. And if animal was false itself, it will just, so if it says that if animal is not true at all, if animal is false, then it will just say print not an animal. So we already know that it should give animal is not dog. If you put it to false, then you see that it will not even enter this part. It will directly go here and execute. So it will come here and it will see the condition is not valid or satisfied. It will come here and print not an animal. Simple as that, right? So this is how nested if and else works. And this has some, there are some things to note about if and else. So typically if and else make your code slower, but in some cases it is not possible to get around that fact. And for your purposes, I don't think even if the code is slower now, it's not a problem. It should just work. That is the first target, right? So what you can do is that you, I also have some problems here, but which you can solve yourself. These are very simple problems. Right? Just check a number if it is positive, negative, or zero. You can write your code here, and you can just see if you can do it or not. I hope you will be able to do it because these are pretty simple. So the next part in flow control. So what we are doing now, why is it called flow control? Because we are controlling how the code flows, right? If this, then the code will flow in this direction. If not, the code will flow in that direction, right? So we are controlling how the code flows, which is why these are also known as flow control statements. So the next very important thing that we need to look at is for loop, right? So what we want to do if I say print all the numbers from 0 to 100? Will you just keep doing print 1, print 2, print 3, print 4? No, right? That is a grossly inefficient way to do things, which is why we have loops. What it can do is that it can say that for any variable in range, so range is also a function in Python, what it will do is that it will generate values from 0 to a number just before this one. So if you go from 0, say range 5, it will generate numbers from 0 to 4. And I say that inside this loop, you start printing stuff, right? So in C++, usually we have braces like this, which enclose the statements in a loop. But in Python, we don't. In Python, indentation plays a very important role. So after a for loop, next line should be slightly like this. If not, then it will throw a syntax error. If expected an indented block after for step. So you have to be a bit careful, right? If you're not careful, then it will give you very weird errors and you will be stuck. Okay, I don't know where the errors are coming from. So it is also possible to generate a reverse loop in the same way. What you have to do is that you say that loop will start from this number, comma, loop will end just before this number, and I will increment in a negative direction. So in this case, if we were to write this, it would have been just simply 0, 5, 1. This is the full range. It will give you the same result, and this will give you 4, 3, 2, 1, 0, which is just moving in the opposite. So these are again very simple ideas. One thing you can do is that for also allows you nested statements, right? So inside one for, you can also have another for, which can tend to even the first index, means whatever the index you had for first for, that also you can put it as the end or the last index for your nested for. So very useful tricks, useful problems to solve using this to understand this part is print these random patterns. So I say I want to print this right pyramid, and if I run this code, it will print this right pyramid. So what you should do before start coding is that you should take a pen and paper and just start executing the code just like the interpreter would. If you can execute the code yourselves on pen and paper, then you already understand how interpreter works, and you will become a very good coder. So even if you take code from ChatGPT, right, in your life, it's possible, right? Why not? It can already write codes. Why shouldn't I ask ChatGPT? If ChatGPT gives you code, still you should sit with pen and paper and see if it does the same thing that you want it to do or not, because sometimes it messes up. So that is something you should practice, and this practice is very well done if you work with this pattern kind of problems. So I also have 2 exercises for you which you can look at later. You can try to print these patterns. This is very easy, right? You just go in and start writing for loops, and that should do. So one important thing about for loop is that in for loop you already know how long the loop should run. So we already said that it should run from 0 to 5, which means it should run 5 times. So 0 to 5 minus 1 or 4, it should run 5 times. There can be one more loop where you actually don't know how long it should run, but what you know that if some condition is not satisfied, stop running, right? That is something you know. Maybe you don't know after how long that condition will be satisfied, but you know that if some condition is not satisfied, just stop. One problem here is that if the condition is never satisfied, then you will go to endless loop, right? The loop will keep running and then you have to terminate. So you have to be careful of that. So one thing to check is that one code that I had to check for code that I wrote to check, show this to you, is that you take any number and divide by 5 until the quotient becomes 0, and you keep printing the quotient. So I have a number which is 134234, and I want to keep dividing it by 5 and check if the quotient is greater than 0, divide by 5 and print the number, and if not, then you stop, right? And if I do that, you see that the quotient, it prints the quotients, and after 1, if you divide 1 by 5, you will get 0.2. where the quotient is basically 0. Quotient is 0 and remainder is sorry, yeah, it's perfectly divisible, but the quotient is 0. So uh, while loop will then stop because this condition is not satisfied anymore. So that is how while loops works. And one very nice problem for you to think a bit is, if I give you any number, you should be able to print all the digits separately, or as I have written here, you give the sum of the digits, which means print the sum of the digits. For this you can use while loop. What is the logic and stuff, I'll leave it to you. Think, write yourself, see if it works or not. Don't ask ChatGPT right away, right? Try yourself once, see what you come up with. Even if it is wrong, it might take 2-3 tries, then you should be able to get it. So if I have a number which is 314, then the output should be 4 plus 3 plus 1, which is 8, right? So then the output is 8. So this is something that should come out. I can give any number and it should give you the output. So what is the takeaway from this section then? The first takeaway is that you can, if you want to introduce branches, you should go through if else statements. If you want to iterate, or if you want to do something repeatedly, you should look at loops. So one loop is for loop, and use for loop when you know how many times you have to iterate, and use the other loop while loop if you don't know how many times you have to iterate, but you know after which condition you need to stop iterating, then you can use while loop. So this also concludes the flow control part, which is again part of the basics only. So this also completes the flow control part.
Hello, Malyadeep, you're not audible actually. Please raise hand, participants. Please raise hand if you can't hear Malyadeep.
Hello Gokul, am I audible now?
You're audible right now. You're audible.
Yeah, I guess the internet got disconnected momentarily. So what did you guys miss some of the parts in the loops? Whatever you have missed, you can just ask. I'll repeat.
Uh, Actually, you were finally explaining the text which I've written over the screen, and after that we couldn't listen anything because of internet connectivity. Hello. Hello.
Hello. Yeah, somebody.
Like,
Did you mute me
hello.
or something?
What happened?
I guess someone
Oh,
muted me. I don't know.
one
Am I?
second. You're audible right now.
Okay. So what
Yeah.
I wanted to ask is that if you have any doubts regarding this if, else, for, and while part, please ask now. Anybody?
No doubt, sir.
All right. So I will assume that it goes for everyone. Then let us move on to the next part, right? Next part is something that some of you might know, some of you might not know. So very important part in Python is that, or any language is that, if you are writing a code which is, let's say, 30,000 lines long, you don't want to put it in the same file, right? You want to distribute it to multiple sub modules or something, and each sub module should contain multiple definitions or functions. They are also known as functions, which if you pass something will give you some output, right? That is how people usually code. So for example, we were using math module, right? So math dot sine, this is a function which takes in an angle in radian value and gives you the sine of that angle. So these are functions. So what you need to also learn is that how to write functions of your own, because not every function is written in Python, right? Some functions are something that you need to write. How do you write? So for that, the syntax typically is, so you have to start with def. Def in Python is used to define something of your own. So you, after def, you put your name, function name, whatever function you want it to be. It can be sine, cos, it can be your name, whatever. But it should always try to make your function name such that by looking at the function name, people more or less get the idea that what the function is trying to do, right? After that, you define that what arguments or what things will the function take as an input from the user.
Hello?
And then it will yes, hello.
Tell me.
Hello. Anybody has questions? Okay. So, yeah, if you have any questions,
like I'll call 10 to 15 minutes before the meeting ends.
I guess someone was unmuted. Yeah. So what you can do is that then you can do multiple stuff inside functions, which I have termed as function statements. And at the end, you may or may not return some value back to the user. Hello. If you have any questions, then say that I have a question and just start, right? If you don't have a question, then it's better to keep muted, or it causes a disturbance. All right. Yeah. So yeah, as I said, any function can also not have return statement. So what I have done here is that I have written a very simple function. What it does is it just takes sum of two numbers. It does sum of two numbers and returns the ID, sum of that, right? It just adds two numbers and returns the sum of that. As I said, the function name should be something which already describes what it tries to do. So that is why I have written sum two nums. And what it does is that it takes num1 as an argument, num2 as an argument, which are the two numbers, and it just adds both of them up, and at the end it just returns those numbers. So what I am doing is, I see this is a very fancy way of declaring variables. So you can declare two variables directly like this. So you just write a comma b equal to 5 comma 2. This works here in Python very well. It works very well in Python. Yes, so a comma b equal to 5 comma 2 I have declared, and if I call this function sum two nums with a comma b, it will return me 5 plus 2, which is 7, and it will be stored directly in this result variable, and then I print this result, right? So one important thing is that the function definition should be before you you call it first time, right? If you call it, define the function later and call it first, it will complain. So what I'll do is that I'll restart the notebook and I'll try to run, and it will give name sum two nums is not defined because the function definition has not been executed yet, so it is not defined. So what you should do is always the definition should come in front, come at the top, and then you should start with the calling part. So this will work fine, right? So what you can do is that you can write any functions, any type of function to find even number, odd number, blah blah blah, anything you can do, right? Using this, the idea of functions. So now we will take a bit of a deviation from again defining stuff. Instead, what we will look at is something called as lists. So lists are very
Sir,
similar. Yes, hello.
sir, what does mean by arguments, sir?
So arguments basically mean what are the input to the function. So if your function can take, let's say, another number, you can say that I want to add 3 numbers. So it means it has 3 arguments. So each argument is separated by a comma, and these are the separate input that the function needs to give you a data. Understood? If let's say I say that I want to add 3 numbers and I also have num3 here, but I don't give num3, means I don't pass it as an argument here. So you see, if I have num1 here, I have A, num2 here, I have B. If I have num3 here, I should have C or some other variable, anything, but it should have the same format, something comma something comma something, 3 arguments. If I don't do that, it should give me an error. Let's see if it gives an error. Yeah, see, sum 2 nums missing 1 required positional argument num3. So what I should do is that I can directly give a number here. That is also fine. And then I run and it will give me 14 because 5 plus 2, 7 plus 7 is 14. Understood? So this argument for the moment I have, yeah, arguments I have considered them to be integers, but they need not be integers. You can, for fun, let us put this to card. Let us also pass a string. See, let's see what it happens. It should complain because I am trying to add an integer to a string. Let's see. Yeah, see. So, and Python is very verbose with the output errors, right? If you get an error, just try to see what it is trying to tell you. Then it is already very verbose. It already tells you that okay, you are doing this wrong. So you just said unsupported operand types, int and str. So you cannot directly add an integer to a string, but instead, if I make all of them to string, then they should work. It should work out because I'm trying to add string to string, and that is perfectly fine. See, 5 cards. Get it right? Did I answer your question?
Yes, sir, but I have another doubt.
Yeah.
If we had a decimal number with the whole number, what will be the result, sir?
So that's a good question. So anytime you have questions like this, it is always best to do it directly yourself and see what happens. So typically adding an integer with a float should give you float. Sorry. See, I made a definition error in definition of the function, which is why it was saying that in which line there was an error, that also it says. So you just have to go through the output one. See. So I added an integer to a decimal point or floating point number and it gave me float. So anytime you do this, it will automatically convert this integer to a float and then it will add. So this 5, before adding what the this line, what it does is it first converts this integer to a float like this and then adds and gives you 7 point. Understood?
Okay,
Same goes with multiplication. If you try to multiply a floating point number with a decimal integer number, it will convert the integer to a float and then do the multiplication. So that is how functions typically work, and also that is how these integers work, right? So you should be very careful. If you want an integer, what you should do is that after this addition is done, you should forcefully convert it to integer like this. Then it will give you 7. Understood? So you have to be careful about all these things.
So,
Yeah.
so in functions, why use return? Because we use print.
So let's say you now instead of sum 2 numbers, I recall the function product sum 2 numbers, something like that. Or maybe let us do a bit more complex something. Let us calculate factorial, right? So I will give the function one number
Yeah.
And what it will do is that it will calculate the factorial for that number. So what it should do, now I want to calculate, let's say if I have 5, if the number is 5, right, what is the 5 factorial? It is 1 into 2 into 3 into 4 into 5, which is 120, right? So what it means is that it needs to multiply all the numbers from 1 up until the number that I have provided and give me the
120.
product of that result. Yeah. So very easy way to do will be, I have to do a range, and that range should go from 1 to 5 plus 1, which is 6, because we said like range will end at whatever number you give minus 1. So that is why I should add one more, so that I can have this loop correct. So if I just print I, you will see that it will print 1 2 3 4 5. Just a minute.
Okay.
Yeah. Oh, sorry, I am not calling the number. Factorial 5. So now we are computing factorial of 5. So so it is giving you 1 2 3 4 5, and I have not returned anything. That is why result is saying none. I have no value. None means nothing. Yes, I have no value. So now you see that I have generated 1 2 3 4 5. What I need to do is that I need to store the product somewhere, right? So let me come up with a variable which I call it product, and I initialize it to 1. I cannot initialize it to 0, because I multiply anything with 0, it will be 0. So that is why I should initialize it to 1, and I should write product into I. Whatever the value of product was, multiply with whatever number the loop gives you, and that should give you the factorial. So one thing is that you may choose to print it directly here, but this is not good practice, because I can also ask that you need to sum this product up, right? You need to sum this product up, or this product will be used later. Let's say I say this product will be added somewhere else to some other value. Let's say I am writing a very bit complicated function, so just give me 2 minutes. I will return product here, product result here, and I will call another function, okay, which will be def add two nums. It will be num1 comma num2, and what it will do is that it will add, or directly, let us do it directly, it will just return num1 plus num, right? And I want to call final res equals to add two nums, and whatever product factorial I got previously, I will pass it here. I got some factorial which will be 120 in this case. I will pass it here and add whatever this B contains to that, and I will finally print the final result. If you have some complex workflow like this, then you need to return, right? If I don't return and just print product, then this is not correct here, right? Get it? So this is a very crude example of why return is important sometimes. You see so what it should do is that instead of printing, it should do return product, and at the end I should be able to work this out. Yeah, 122, right? So return is sometimes very important, and it is probably most important in function. Your function does something and does not give you a value, then that is not correct, right? For example, that math.sign function that we had, it gives you a result because it returns that value. So return is very important if you want to do that. I would always suggest, if you are writing codes, your function should always try to return something, right? Something, even if let's say it is not returning anything worthwhile, it can even return 1, which means 1 means the function execution was successful. That also can serve as a check, that if 1 is returned, it means function did not have any problems. If it does not return 1, then it means function has some problem. This sort of checks you can also include, and that will make you a better coder, right? Not everybody does that. these are some of the stuff that you should worry about, but you will learn these things through practice. So what I wanted
Sir,
to
I have
cover
a doubt.
next, yes, go on.
Sir, can we use case statement instead of if-else statement?
Yes, perfectly fine. So I chose not to discuss about the branching switch case statement. So what you could have also done, instead of if else statement, you could have just direct. So if else, what it does is that if you have a block like this, if elif else, so what it will do is that it will first go to if, see if this condition is satisfied. No, then it come to elif, then it will come to else. That is how it works, right? Switch cases are very useful if you are working with sorry. Oh, I guess it was switch and then case. So usually I don't use switch case statements because they are very slow, extremely slow. But if you are willing to use switch case, then you should have something like switch something. Then you have case 1, you have case 2, you have case 3. You can have multiple cases like this, right? And at the end you can
Yes.
have a default case, right? Something default. So I wrote this in C syntax because I don't remember the Python syntax, because as I said, last time I have used switch case, it was 6 years ago, I guess, because it is very slow and I never use it, right? So switch case, but yeah, you're correct. If you are doing some complex workflows, in some cases it is really required. Web development or application development, these are required sometimes. So switch case, if you use, then what it does is that it goes to the switch and it will check that which case satisfied and go to that case and execute, right? But that checking takes a lot of time, which is why I don't use, but it's perfectly fine, right? In flow control, it also comes very handy in sometimes. So what you should look at, I will add this in this Jupyter notebook so that you can look at it later. Look at switch case statements. I will not discuss it here because it's not very useful. Most of the scientific computing cases or engineering cases, most of the times it's not very useful, pretty slow. But you can look at it, right? No harm and foul.
Okay.
Right? Yeah. So shall we proceed with the list?
Yes.
Yeah. So lists are very useful containers, right? They can contain multiple types of data inside a single entity. And these are very similar to array in C. What in C we have arrays. Lists are pretty similar to arrays in C. But what is one of the nice part about lists is that in C arrays, you can only store one type of data. So it can either be integer, or it can either be float, or it can either be strings. You cannot store let's say 1 and 8. This is not possible in C++, right? There are some complex data types which are in newer versions of C++ that can do this, but typically not used as much. So in Python it is automatically allowed. So what you can do, you can have a sample list as I have declared. First element is dog, right? Second element is 4, third element is true, and last element is 7.25, which means it has more or less all the data types that we have discussed. And indexing in Python is similar to C, but different from Fortran and MATLAB. So it starts with 0, then 1, 2, and so on. Which means if I tell you to go to the third element, your index will be 2. If I go to the first, ask you to go to the first element, your index will be 0. This is something you should imbibe inside your mind if you are working with Python. So what I'll do is that I will print what the sample list after I have generated it or directly initialized it, and I will just check what type of variable the sample list is. So it will just tell you that it is a list. Now,
Sir, I think someone has muted you.
am I audible now?
Yes, sir.
Hello.
Yes, sir.
Yes,
Yeah,
sir.
yeah. Yes. So don't mistake. I guess someone is muting me by mistake. Yeah, let us proceed. So we have sample list. We had a sample list value, and what we will do is that we will ask this copy function, which is a list function. It will copy whatever data was there to this list 2 value, and you see, yes. So if I execute this code, you will see that it has copied the sample list value to list 2, because when I print list 2 now, it is printing exactly what the sample list was. Now there are few other functions. If you want to add something to the at the end of this list, whatever you have, you can use the append function. So what it will do, whatever you pass on to this append function, it will add to the end. So what will happen is after 7.25, this high will be added. So if I see, now high is added to the end of the list. You can also so as I said, indexing works starts from 0 in Python. So if I want to access some element in the list, I simply call the list and inside third bracket put this whatever index I want to access, and the element at index 2 is 2 of the list is true. So yeah, I can go to 4. Maybe it should give me high. Oh, sorry. See, because sample list does not have a fifth element, so it is telling me list index is out of range. So instead I should go to 3 and it should print 7.5. Understood? So Python is very good with writing up errors. C++ doesn't do that. C++ will directly say memory error and you find out where the error happened. But Python is not like that. It is very friendly in that sense. So it will tell you. Yeah, append is something we have already covered. So what we can also do is that we can delete certain element in the list, and by telling which index we want to delete, right? So I say that we delete the index, whatever is at index 1 of the list, and it is 4. So if I do that, I have to use this pop function, sample list dot pop. Then inside the bracket, I have to tell which element in index, which element, in element at which index I should pop, and that is what it does. So you see that now 4 is not there, it's gone, it has been popped out of the list, right? So these are some of the functions that may come handy in list, and you should take a look at all these functions that are available here. You can also do these things by for loops, right? You can just create a separate loop list again and copy everything, and that is the same as doing sample list dot copy. But Python gives you some functions which make your life a lot easier and decrease the number of lines of your code. Sorry, yeah. So that is something that is one of the nice points of Python, that it is very user friendly. And hello, yeah. So these are some of the things that Python offers you in terms of list, right? So this is something very important when you work with complex problems in Python, right? So this is a, let's say, a bit involved example where what I do is that I have a list of string, and that list of string I pass it as an argument to a function which finds the longest string in the list of strings. So what it does is that it takes the string list and it iterates through all the elements in the list, and what it does is it just measures how long the string is, right? For that, to measure length of any string, you can use len function. So if I have a string which is, or let's say list, anything, if I have a string called cat and I say len of a, it will just give me 3, that there are 3 alphabets or 3 elements in this array. So what I could have also done is instead put things inside list like this, and I could have said what is the length of this list. So the length of the list will again be 3 because there are 3 separate elements here, and it will again give me 3. So this way you can find out what is the length of the string. So that is something I have done, and what I said is that whatever length value you had previously, if the length of current string is more than that, then you set the longest string to be that new string, and the length of that string should be len of whatever string you have found to be the longest one, and then return the longest string and print. So that is what this function does. Let's see if it works out. So is aeroplane the longest string here? It has 9 characters, others have 8 or 9. Am I counting it correctly? Yeah, fine. So see, I have made a not a syntax error, but a slight logical error, right? You see, aeroplane and Andromeda, both of them have same length. But what it is telling is that aeroplane is the longest string because of the condition that I've put. Right? If the length of the current string is more than the length of the whatever previous strings we have encountered, if that is true, then you set the longest string to whatever string we have has appeared from the list right now. And if aeroplane comes out to be the longest first, then even if Andromeda is has the same length as aeroplane, it will never be the longest string because I have put a condition which says that it has to be greater. If I would have said greater than equal to, you will see then the output will be Andromeda. Let's see Andromeda. So this is a logical error. So instead, what you should do, what your function should do is that your function should find out all the longest strings. So if let's say 9 is the largest, 9 is the length of the largest string, you find out which string has length 9, and then you see that the function will become a bit more complicated. So that is how you write. So to not give you this ambiguity, I'll just delete an R, and now it will give you aeroplane, which is perfectly fine because aeroplane anyway is the longest string. But this is something you should figure out, right? Find a function that, write a function that will print both Andromeda and aeroplane, and it will say that there are two longest strings of length 9, and the string is known as aeroplane or Andromeda. So this is something you can try it out. So these things will help you develop your rigor when you are writing codes and stuff. So one thing that you should ask me, because I have not talked about, is what is enumerate. What does enumerate do? This is a new function that I am using, right? So what enumerate does is that if you provide it with a list, it will give you an iterator, just like range or something. And what it will do is that it will give you two iterators. First iterator is what index are you on, and the second is what is the element at that index. So if I say enumerate list of strings, you will see it will give me an object, right? It gives me an object. And now if I do the same thing and say in yes, and print itr comma string, it will give you 0, which is the index, and string. What is the 0th string? It's dog. First string is cat, second string is aeroplane, right? So that is how enumerate works, and it will come in pretty handy when you are talking about working with strings or large arrays or something, and you need to do these sort of operations. So you should, I request you to practice all this all these problems. You will also find a lot of problems in HackerRank and CodeChef, which led to manipulate strings, and this will be very useful to help develop the way you think while writing your codes, right? So this is something you should work out. So this was one of more involved functions example, and I also have a playground here, so you can write functions and play around here. You can solve this problem, which says that write a Python function to find how many odd integers are there in the list. So you already know 1, 2, 3 odd integers are there, so you should be able to print 3, right? So that concludes the list and function discussion, and what I'll move to next is called classes and objects, right? And this is something that is not very easy to cover in a small workshop like this, right? Classes and objects come inside a larger, broader subtopic also known as object-oriented programming, and you'll find books which are dedicated to object-oriented programming, right? And object-oriented programming languages are C++ and Python, right? Java is also an object-oriented programming language. So we cannot delve too deep into these concepts in this workshop. But what I will show you here is that what is a class, what is the most basic definition for a class, and what does it do, right? Why would anybody use class, right? How does it work? And if you find it useful, then please go look into some books that I will suggest at the end. Some books are already suggested here, or you go to YouTube and look at few lectures and see how it works, how to write and stuff, right? So I will give you a very simple example of a class. So class, what it is basically, so you know that if you want to build something, right? If you want to build, let's say, a screw jack, which is used to raise your tires so that you can raise your car so that you can change your tires, right? So screw jack, before manufacturing screw jack, there is a design drawing, right? That is the blueprint of the screw jack, and that blueprint is one, right? Using that single blueprint, you can create multiple screw jacks. So classes are like blueprints. So they give you a blueprint of what a screw jack should be or an object should be. So using this blueprint, you can create multiple different objects, or which are screw jack in this case, right? So class, I define a class which is called animal. Now you know that animal can be dog, cat, lion, tiger, anything, right? And any animal should have three attributes. These are called attributes, right? What attributes should it have? One is species. It should have a species. Then it should have some age, and it should have some color. That is some attribute that I have provided. You can also write genus. Biology loving people can write genus, write the entire taxonomy, right? Whatever. You can also write number of legs, maybe one of the attributes, right? So for the moment I have provided three attributes, and in every class has one function which helps us initialize that class or to initialize the object, right? So if you create an animal, you have to pass these values: species, age, and color, and it will assign those values, whatever you have passed, to these attributes. And attributes of a class are accessed using this type specifier, which is known as self. So if you say self.species, it means that you are changing the attribute of the class. If you don't write self.species, then it will say that no, I am not changing the attribute. It is some other variable or something, right? Yeah. So sorry about the mistake. So ideally this should also be self. Yeah, perfect. So yes, this function that initializes your object is also known as constructor. You will find this thing a lot in object-oriented programming language. Constructor is one of the most important functions a class can have. And there are also functions called destructor, which destroys the class. So if you don't want animal, you want to destroy it from the world, you say call the destructor. But destructor I have not written down. You can look at it in any of the books. So now all the class can also have functions, their own functions, which can be called to manipulate that class. So let's say my function, what it does is that it just prints the species. If you call the animal and ask it to get its species, it will just print the species. Similarly, get age or get color. I will write one more function for you. What it does is that it increases age by 1 year. So what it does, it will increase the age. Let us use a shorthand notation. This means self.age, sorry, equals to self.age plus 1. This is basically what it means. It's a shorthand notation, right? Increase increase. Let me also give a then function argument so that you see how we can also find pass function arguments, right? So what we will do first is that we will create a dog object, and that dog object will be stored in a variable which is called dog obj. So the dog obj, what it does is, sorry, sorry, yeah, sorry. So self will come, sorry, inside only functions and not outside. That is a mistake. Now what we will do is that we will create a dog obj like this animal, and I should pass the species, which is a string called dog. Age is 4 and color is brown. And what I will say, let us print what is the species. So what I will do is that I will just say dog obj get species, and it should print dog. Yeah, it prints dog, right? I can ask it to print age. Okay, age is done. I can also ask it to print color, brown, right? So this is also fine. Now let us call that other function which we have written. So dog obj increment age, increase age. How much should I increase it by? Let's say 5. It will be a very old dog, but let us increase it by 5, increase age by 5, and then print the age again. See, now it is 9. Age is now 9. Right? So this is how you can manipulate the create right class, and you can create objects which will use the blueprint of the class, but can be multiple different types of objects, right? I can also create a cat obj using the same animal class. Oh, I have already done it. Yes. So see, I have a cat obj, and it does all the same things. I can create tiger. I can create lion. I can create any number of objects. I can create these objects inside a loop. I can do so many things when I have access to class object thing. So what you see, I have only written the class once, but using this class as a blueprint, I can create multiple separate independent entities which have the same attributes and which has the same properties, but the values of the attributes, which means the species, age, and color, are different, right? So this is the use of class and object. So it can act as a container of multiple different types of data types, which you can manipulate on the fly, and it encapsulates it. It acts as a capsule. It keeps everything inside, and if you want to change something, you poke it and say do this, do that. Right? So class object can become very handy if you are writing very complex code. For example, the codes that I write, the code usually that I work with is typically more than 35
बोल दो
40,000.
जल्दी ज्वाइन करने के लिए, जल्दी खत्म कर देंगे, बहुत कम लोग आए हैं, सबको बोलो जल्दी जल्दी ज्वाइन कर ले.
Hello, someone is unmuted. Hello. Yeah, please stay on mute if you don't have a question. It just causes unnecessary disturbance. Yes, so that is what class and object typically does, right? So that is something, if you find useful, please look into it. I will not discuss object oriented programming here because simply there is no time here. We don't have time to discuss object oriented programming today, but these are few books which you should go through if you are more interested in becoming a nice more nobody's a good developer, really. Nobody's a good developer, but if you want to be a reliable one, then you should look into all this very carefully, right? Yes, so that also concludes our class and functions and lists part, right? So this might have been new to you, so I would stop for 2 minutes. If you have any questions, I'll try to answer that, or else we'll move into something that is more useful for engineers. Let's say for engineering problems, some things that are more useful. So do you have any questions?
Please ask if you have any questions.
No, sir, all clear.
Yes, someone is telling something. Hello.
All clear, sir.
No questions, right? All right.
Like if anyone has doubts, they can raise their hand. We can wait for a couple of minutes, Malady. If nobody is raising hands, then we can end the meeting. I think.
Yeah, so I'll wait for 2 minutes. So if you have any doubt, just think of it and raise your hands. I'll open the notebook so that you can create see.
Sir, would you explain me about the self once again? I can't understand it, sir.
Yeah, self is something known as a type specifier. So what it does is that if you add a variable, if you have a variable and you say self dot that variable, it means that this variable belongs to the class, right? It is an attribute of the class. If I don't put self, let's say, let us create a variable which is, what variable should I create? We have species, age, color, number of legs, 4. Now I have not put sorry, 4, yeah. So I have not put self in before this one, so this is not an attribute of class. So if I try to print the number of legs of this dog obj, it should not work. Let's see, it will say animal object has no attribute number of legs because it was created here. True. If I say that print number of legs here, it will print 4. It will print 4 here. See, it has printed 4 again here, which is the number of legs. Maybe if it is not clear, let me say number of legs equals, right? It is printing, right? The variable exists, but only inside this function. As soon as the function execution is completed, it is lost. It is not retained in the class because it is not an attribute of class. So if you want to make this an attribute of class, you have to add self before that. So if I, let's say, write self dot number of legs, right? See, it has retained the value. Now it is an attribute of the class. So any attribute, if you want to put it as a class definition, right, it should be in the definition of the class. You should add self. Self tells that this is a property of the class. If there is no self, then property of class is not there. And all the functions, if they want to access the properties of class, they should have self, or else you won't be able to access them. So this self is very important if you want to access properties of class. Is it a bit clear now?
Yeah, sir, clear, sir. Thank you, sir.
Yeah, yeah.
There is another doubt from a student named Chandrasekhar.
From? Hello.
Yeah, a student has raised his hand actually. Chandrasekhar. You can unmute and ask your doubt.
Yes, Chandrasekhar, you can unmute and ask your doubt.
Yeah, I think he
don't
raised by hand is raised by mistake.
Yeah, okay. So this means we can proceed, right? Fine.
Yes, like if nobody has doubts, I think we can proceed here.
Yeah. So let us proceed to the next part, which is actually the last part that I wanted to discuss. These are some advanced libraries which are typically useful for scientific computing, right? if you want to do differentiation, as someone was asking, I didn't get the name, sorry. For differentiation, then numerical methods, if you want to do Newton-Raphson or those sort of things, right? You want to solve a matrix equation. You want to take determinant of a matrix, eigenvalue of a matrix, right? All these things, if you want to do, advanced libraries already exist in Python, right? And they are written by experts, highly optimized, and you don't need to worry at all that whether it is working or not. They are well tested, right? So one such now library that you should be aware of, and it is now synonymous with Python more or less. It's known as NumPy, right? So NumPy is a numerical library, and that it gives access to a lot of mathematical functions. Now you may already ask that, okay, math also gives us access to mathematical functions, right? But what is the difference between math and NumPy? So NumPy can work directly on arrays, even single numbers, anything works. And secondly, math is written in Python, so it is pretty slow. Okay, NumPy is written in C. What it does is that it just allows you to call a C code from a Python script. So since it is written in C, it is extremely fast, right? Because as we discussed, right, Python is very slow because it does execution line by line. But NumPy is written completely in C and also a bit of Fortran, so it is extremely fast. And also it has various array manipulation functions. I will show some of them. All of them we will not be able to discuss because NumPy requires a small course on it, right? And it also has large scale linear algebra calculation functions, and it, as it is written in C, it is extremely powerful and fast, and it is a must have tool. Even if you are trying to do AI ML later using some fancy libraries called TensorFlow and PyTorch, they are nothing but a fancy extension of NumPy, which are targeted towards larger data or complex data handling. So we will first discuss NumPy, and NumPy is something that you have to install, right? How do you install packages in Python? You use this command, pip install NumPy. Some people will use Anaconda, so they should do conda install NumPy. So these things are already there in their documentation. I have provided a link to their documentation. It's pretty easy to set it up, right? You have Python, you can have NumPy direct. So what we will do first is that we will create some arrays with NumPy, right? So previously we were working with lists, right? And lists could have stored floating points, integers, strings, everything all together inside a single entity. But NumPy, since it is written in C and it has to be very fast, it works like C. So what it will ask you to do, if you want to create an array, it should only have either integer or float or string or anything which is of same data type. You cannot have multiple data types. So when I say np, so I have imported NumPy as np. So whenever I call np, it means I am calling NumPy. So just to shorten the name, I have used np. You can use your name also, whatever works, right? Now you say np dot zeros. What it does is that it creates an array full of zeros. And what should be the length of that array? You specify it here, 5. So you say 0 array is equal to np.zeros 5, and you see that the first array created is just a array of 5 zeros. That is what it does, right? And you see there are 0 dot, which means they are floating point numbers, right? By default, it creates floating point. You can ask it to create integer by saying b type, data type equal to int, and it will create integer. Understood? So let us stick to floating point for now. Similarly, you can create np.ones5, right? And it will create 1 1 1 1 1, 5 ones. There are also very fun functions which will create random data. You say np.random.random5, and it will create an array of size 5 which has random data. If I run, every time you see these numbers are changing. Look at this array. Look at this. You see, sorry, the third array basically. You will see that these numbers keep changing because these are random, right? One very useful type of array creation is linspace, which says is that you will create an array from one which basically contains the numbers 1 to 5, and he will divide that interval between 1 to 5, including 1 and 5, into 5 parts, and he will create an array of this size 5, right? So what it does is basically it does 1, 2, 3, 4, 5. If I would have said 4, you will see some decimals appearing here. See 1, 2, because it's not exactly divisible, it will give you some weird values. If you do this 10, you should get, sorry, yeah, now it gives 1, 1.4, 1.8. So it will automatically divide and give you the perfect interval. You don't need to worry about that. But let us stick to 1 to 5 for now. So these are some arrays that you can create. And one nice thing is that many of you might have used MATLAB in your institute as of now. And MATLAB, whatever functions you use in MATLAB, the same functions are also there for NumPy. See, zeros is there in MATLAB, ones is there, linspace is there, right? All these functions are already there in MATLAB. So when people tried to develop, they were already trying to develop something which gives you many of the functionalities that MATLAB has. Now MATLAB is a paid software, Python is free, right? So you can, instead of working with MATLAB, start working with Python using NumPy, and you should be able to do all the things that MATLAB does, right? So some mathematical functions of NumPy, they are all the functions that math has, NumPy also has, right? So see, I have created an array which is angles, and it has np.linspace from 0 to pi. Now see, NumPy can give you the highest precision pi. You just have to call np.pi, and it will give you 3.14159 whatever. So if you just print np.pi, it will give you pi. See the precision. There should be 16 digits here because our machine has the precision of 60, right? So see, so now I run this and see angles in degrees. If I create 7 intervals in 7 angles in between 0 to pi, then I have 0, 30, 60, 90, 120, 150 and 180. Understood? If I take the sine of those angles, I will get these values. Sine 0 is 0. Sine 180 is again 0, which is given by this very small number, right? Then sine 30 is 0.5, right? Sine 60 is root 3 by 2. Sine 90 is 1. Same sine 120 root 3 by 2, and sine 150 is again 1 by 2. So similarly, you can get cosine, np.cos, and also np.tan, right? And now we know tan 90 is undefined. So here undefined doesn't come. What comes is that it's a very large number, extreme number, 10 to the power 16, which is a very large number, tends to infinity. So this is how NumPy usually works. So you need to understand how these things work so that you can manipulate them later, right? So for the entire suite of NumPy functions in NumPy, just click on this link on the notebook and you get to the documentation. Everything is there, everything, right? You just have to dig through stuff what you need. And now your life is even easier because ChatGPT will already give you if you are searching for something, right? Now see, matrix multiplication using for loop and NumPy. So what we want to do is that we want to create two matrix, and matrix can be just created as array which are branched together. So see, this is a big array. This pink brackets give you the boundary of big array, and this inside this big array there are small arrays which also have the same order basically. So this is a 3x3 matrix. Let me print. You see, this is a 3x3 matrix containing all of this, right? So what I want to do, I want to calculate matrix multiplication of this mat1 with mat2. Mat1 dot mat2 matrix multiplication, and I want to see if I can do it using for loop. So I have already written the code here to do it with for loop. So we'll look at this later, right? These are just simple logical steps, and it gives me some matrix multiplication values. What I can do, instead of writing all these lines, I could have just called NumPy and said np.matmul. Matmul is a function to multiply two matrices. Now you have to be aware of whether this matrix can be multiplied or not. You know the condition, right? M cross n, n cross p, This is the condition that you need to satisfy. If you satisfy, you can just run np.matpool and the result is exactly the same. To show you that the result is exactly the same, just take difference and you see that it's 0. Whatever result I have minus whatever result numpy has, difference is 0, which means they are really the same. And this shows you that how easy it is to do all these things quickly, right? What I can do, we can also do, maybe I don't know whether these matrices are very well defined, right? So let me take inverse. I think inverse was this. No, yes. So let me try to invert this matrix mat1. I don't think this is a singular matrix, I think. Yeah, see, it even says, because you know what is a singular matrix, right? If the determinant of a matrix is 0, it means it is non-invertible. It's a singular matrix. So see, I can just call determinant and it should print 0. That is why it tells that it's a singular matrix. So everything is so easy. It has written down everything. Right? If you ever want to know how people manage to do this, if you are on Linux, I can show you where you should go to see. If you're in Windows, I don't know. Sorry, I have never used Windows, Python in Windows. So it's supposed to be local. Sorry, side packages. Yes. Now let us search for NumPy. All the Python functions that I modules that I've installed are here. Let me go to mp.linalg. So these are the functions that we have just now called, right? Now let us search for ing. So you have to go through it a bit. See, this is the definition, function definition for the function just now that we called, right? And it has written down everything that you require to say that whether it is invertible, not invertible, what is the inverse or everything, right? So everything is written by someone, like some expert. Let us see if mat2 is invertible. Oh, that is also not invertible. I should have created a better matrix. Can you give me some matrices or should I directly write? 6 random numbers 1 4 1 8 10 1 3. I hope this is invertible. See. See, so this matrix, its determinant is 100 and the matrix is invertible. If you have done a course on linear algebra, you also know something called eigenvalues. You can also find out the eigenvalues. I equals of this matrix A. See, the matrix has an imaginary eigenvalue. So everything is already coded so well. You just have to call this. If I were to tell you to write a matrix, write a function that will invert a matrix in Python, you would have struggled at first, right? You have to go through the algebra first, and you have to write it in a way such that gives the correct result first, and then it should not be very slow. If I give you 1000 cross 1000 matrix and inverts takes 2 years, then there is no use, right? So these are really optimized, written by experts. So this NumPy is something that you have to get used to if you are looking into data analysis, right? I'll keep these codes here so that you can refer to them later, right? So one more thing is that one more thing about NumPy that I said is that NumPy is pretty fast, right? Compared to pure Python, it is extremely fast. So that is something I'll show you. So I have written a dummy function here, which is known as compute for. What it does is that it just takes an array as an input, which is ARR, and it iterates through all the values in that array. And what it does, it just takes the exponential of that value, takes the logarithm of that value plus 1, right? Whatever value is there plus 1, takes the logarithm and then multiplies it with the square root of that value. So it's just a garbage operation, and it has no physical significance. Just that I wanted to do some operations I am doing here, and I will do it using a for loop, simple Python for loop, which is a Python function here. And I will do it also using NumPy. See, entire thing, instead of doing it element wise using a for loop, I am doing it using directly calling the NumPy functions. So we will see which one takes shortest time. So see, I have taken a fairly large array which has 1 lakh elements, and what I want to do this operation on this big array, large array, and I want to measure how much time it takes. So percentage time it is a magic function in Jupyter. You can search what are magic functions. And magic functions are something that helps you get some complicated data from a function call or something. So for example, what it does here, time it, this magic function, what it does, it runs the whatever line code you are asking it to run, it will run multiple times, and then they give you the mean execution time in seconds that it took, right? So that you understand that how much time am I spending doing this stuff, plus minus standard deviation. So it also gives you a statistical average, so which is very nice. So let me run all these things, and we will see that how much pure Python time, how much time is taken by pure Python and how much time is taken by NumPy, right? So let us see how much time pure Python takes. So how much time did it take? It took 37.8 millisecond plus minus 126 microseconds, right? So this is mean plus minus standard deviation. So now let us do the same with NumPy, and let's see how much time NumPy takes. So you might be thinking that it is taking longer time than this compute function to do this, because this is not the reason. This is not due to this line is slow. This is because it could run more loops in the time that we have allotted. It could run more loops of this line. It could run this line 1,000 times for 7 separate cases, right? Which means it ran 7,000 times in total in 11.7 seconds, and this one only ran 70 times in total in 3 seconds, and the time taken by each run was 37 milliseconds, and using NumPy it is 1.44 milliseconds. So how much faster is it really? Some estimate, it should be close to 30 times fast or 26 times fast. So NumPy here, you see, for this simple operation, it is how much faster? It is 26 times faster, right? So just it also took less lines, less effort, and it is much more faster. Reason why it is faster is because the codes, whatever code you see here, whatever I showed you opening that file, those things are written in a combination of C and Fortran, which themselves are extremely fast, right? Because they are compiled language. So this is something that I wanted to share about NumPy to show you how easy it is. I cannot show all the capabilities today, right? It is not possible, simply not possible in the time constraint that we have. But what I tried to show you, that it is easy to work with and it is useful. And let's be honest, it will be very, very important for you if you are working in scientific computing using Python, right? And also, cherry on top, it is also extremely fast compared to pure Python because it is written in C and Fortran. Now, one question you might ask me. See, I want to use NumPy. Fine, I want to use NumPy, but whatever things I want to do, they are not directly written in functions like NumPy functions, right? I want to do something complicated, and what I need to do, it has to be written by me. But I also want to accelerate that. I don't want that I write the functions and everything myself and it is dead slow. I don't want that. I don't want that it is dead slow. I want to make it fast, but the functions are supposed to be written by me. So the question is, can we make this function faster, right? Can we find a way to make the execution of this function itself fast? So yes, there is, right? So Python codes, as I said, are interpreted language, right? Python. So which means that it will run each line one by one. You don't want that. What you want is that you also want the Python line to Python code to be compiled and also executed faster. So there is one third-party library called Numba. It is a combination of NumPy or numerical computation plus Mamba. Mamba is from Black Mamba, which is the snake. It is very famous for its speed. Black Mamba is very famous for its speed, which is why they have coined the term to make Numba. Right? So Numba is a third-party library which can compile. So see, Python is an interpreted language, but it will still compile during runtime. It will compile and execute it as an executable, which makes it extremely fast, even as fast as C or Fortran, right? But what it requires is that you write the codes more explicitly. You are more careful about data types. You are more careful about whether I am not accessing outside the list, because it becomes more and more native. The right word is native, because it is more and more closer to what processor understands. That is why it has to be written in a more explicit fashion. But it is very simple, right? What you see is that so what it does is really it just compares. So Sneha, I will require 10 minutes to complete. So if you don't mind, is it fine?
Yeah, it's fine. Yeah.
Yeah. So 10 minutes I should be done. Yeah. So what we can do is that you can just import the library Numba, which I have, or which is already installed. Same way, you can just install it like pip install Numba. And what you have to do is that on top of your function, you just have to put this line @numba.ng. What it means, what it doesn't mean, for that you have to contact me and we have to go through a bit of high performance computing part, right? So let's not worry about that. These are also called decorators. So for the moment, you can, if you just put @numba.ng on top of your function, whatever Python function you have, and you just execute it, you will see how fast it gets, right? One caveat with this is that since this code is now not run in Python, it is run in some compiled language. What you have to do is that you have to first call this code with some test data, which must be ideally should be smaller than the main data, so that this code gets whatever code you have written gets compiled, and after it is compiled, then you give it the main data and it will give you the result, right? So what I will do here is that I have this function which is decorated with this decorator, which is number.ng, right? And I will call this function. I have defined the function and I will call, and I will see how much time it takes to run, right? So let's see how much time it takes to run. It is doing the same operations, right? Whatever operations this Python function and the NumPy was doing, we are doing the same operation. See how much time it took. It took 698 microseconds. How much time we were taking previously? Milliseconds. In milliseconds, right? So let us do some simple maths. 37.8 millisecond, which means we have to multiply it by 1000 divided by 698 microseconds. 54 times faster, right? And it is even faster than NumPy. So NumPy took 1.44 milliseconds. Now it is 2 times faster than NumPy, right? So Numba is something that you should look at if you are interested in high performance coding. If time is a constraint for you, you want to accelerate it, you should look at number, go through their documentation, see what can be done or not done. Most of the things you have to learn it yourself, right? I can give you some resources, some examples, and motivate you to look at that, but learning has to be, most of the learning has to be done by yourself. So I have number, for number, just search number, right? And it is the first thing in the Google, and just go and go through their documentation, see what it can do, right? So number is something that you should also look at. And the last part that I wanted to talk about here is that, okay, you will do a lot of computation. You will do process simulations, you will do computational fluid dynamics, you will do some AI ML stuff, you will take computer vision, take an image, do something. But everything has to be visualized at the end. You need to make graphs, plots to find out what is going on in the system. How do I interpret that, right? You want to put those graphs in a report and something, right? For that, the library that we have is called matplotlib. And good thing is the syntax is very similar to what MATLAB does. So it is very happy with NumPy data. Right? What you will do is, what you can do, you can just generate random data. For the moment, I have generated random data. I have generated an array which is X, runs from 1 to 10, Y, and I have created another variable array which is Y equal to X. So basically this is a straight line with a slope of 1, which means the angle made with x-axis is 45 degrees. So if I run this code where I am telling it to plot x comma y, so x-axis will have x, y-axis will have y, and x label of x-axis is x, label of y-axis is y. So it will just simply plot. You can do so many things here. You can make the lines wider. You can change the color of the line to blue. It's already blue. Let us make red. See, does it all. You can also add legends and everything, right? So what I want you to do is, it's probably one of the most simplest things that you can do. It's mostly manual job. You have to find out how to do this and just do that. So what you can do here, you can create a graph of y equal to sine x from 0 to pi. This is something that I have left as a homework for you. Similarly, you can also generate 2D plots. For example, I have created here a contour. So for contour, you need x and y, and you also need a function, two-dimensional function, which is a two-dimensional function, which is a function of these variables x comma y, right? And what I do is that I have created the function which is x square plus x square multiplied by y square, and I am plotting it as a contour, and contours are also plotted with values. So what it says is that here the values are 1 and here the values are 0, and in between there are values which are in between 0 and 1. So what you can do is that you can create using NumPy, obviously. See, I have also used NumPy here. You can create some more complicated contours here. So what you can do is go through all these notebooks, try to understand the basics first, and then you start doing whatever you want. I suggest pick a problem of your own, whatever problem. Let's say in transport you may be showed how to solve the heat diffusion equation. Try to solve it yourself using Python, right? That is how you will learn to do. While doing that, you will already learn NumPy, you will already learn Matplotlib, and if you want to make it faster, you can also learn number. And one problem, you learned everything yourself. So that is something you can do. And since I was told that we have undergrads from 1st to 4th years, so I did not include a heat diffusion problem because it also introduces a lot of mathematical preliminaries that I should go through. Instead, what I came up with is a very complicated, still a complicated problem, which what it does is that you have an ellipse, right? So I'll just directly show the animation. So see, this animation is created in Matplotlib. The simulation, the movement of this ellipse has been done in using NumPy and Number, combination of both, right? And you see that the ellipse rotates and translates based on whatever velocity and angular velocity I give. It just rotates and translates from diagonal to diagonal. I can make it go from left to right, go from right to left. What I am doing, I am just solving the kinematics equation that you know, dx dt equal to velocity, and d alpha dt, which is the inclination of the ellipse, It is a rotational motion, so it should be d alpha dt equal to omega, which is the angular velocity. And for that, I have this entire code. So if I run it, it will regenerate that animation. So let's see. To show you that I'm not messing around with you, let us delete the animation, right? And I will change the velocity to something else. So let me see. If you want it to move more faster, like a maniac, let us increase the angular velocity. And what I will do is that I will just run everything. See, and what is even more fun, you can also add progress bars using a library called TQDM. You can also run progress bars. Similarly, if you install games or something, you will see that these progress bars comes alive, right? So similarly, you will see progress. See, so these things also you can do. You can make things look very, very nice. Now the animation has been created, and if I play the animation again for you, see, it's rotating so fast and translating. So this is a very pretty advanced demonstration of what Python can do without delving into any science. We are not doing science here. The only science is kinematics equation, right? That is the only science that we are dealing with here. And even with that, you can do simulations like this, move them, create animation. See, this is the kernel to do animation. So what I want you to do is that I don't want you to break your heads over, okay, you should be able to write this the next day. No, not possible. But if you go through these basics well enough, you should also be able to write a code which looks like this and does all the things that I just claimed. See, it is not as easy, right? What it is doing, it is exiting from these boundaries. It is appearing from the other corner, right? Which means the logic also contains the fact that these boundaries are periodic, which means anything that exists from one direction should appear from the other direction. So these things are not trivial. So it does take some effort to code in, right? And this is something, if you could do these sort of problems, if you could solve, you will really be a valuable asset to anybody, right? And valuable asset to obviously yourself and to any company or any research group, anything you are working with, anyone you are working with, you will really be a very valuable asset, and you can call yourself a reliable coder. That is what I said, right? You cannot be an expert. There is always things that you don't know. I don't know many things about Python even after spending so much time. I don't know many of the things, and still I have to go back to documentation, right? So that is what you have to aim for. Cannot know everything, but whatever comes in your way, try to do it. Some numerical problem was solved in your computational methods class, come to your home, come back to your home or hostel, you just code it yourself, see if you get the same result, right? That is how you learn. And if you can do that, I guarantee you that your concepts will be pretty clear, right? So that is all I had for today to discuss with you guys, and I will leave it here. And if you have any questions from the entire session, if you have any questions, please feel free to ask, right? If you want to know something more other than what that is also something I can accommodate in 2-3 sentences. Now it's up to you. I hand it over to you guys, and just ask questions, right? So was it too much, or are you still processing whatever I talked about? That is also fine. Can be a lot.
Sir,
Yes.
Python list or only numpy arrays?
I didn't get your question. Can you repeat?
Does number work Python list or only numpy arrays?
It works with list also. You can also work with list, but typically list also should contain the similar data types. Okay, you cannot send list to number which have heterogeneous data types, which means string and all these string floats are combined. I don't know if the newer version has it or not. At least the version that I was using last day, it does not have, right? I would always suggest, if let's say you are doing is writing a solver that does computational modeling of fluid, right, or it does a process simulation, most of the times you will only require working with floats and integers, right? So I would always ask you, please stick to numpy arrays, because they are uh, initialized in memory in a C++ format, right? And that is the fastest format to access and write in. So I would always suggest, please work with NumPy array and club it with Numba, no problem, right? Numba is perfectly happy with NumPy arrays and many of the NumPy functions as well. So you will have a very nice time working with Numba if you have NumPy arrays. Some things I have not talked about. Using Numba, you can execute your code in multiple processor cores as well. So your laptops have 4 processor cores, right? Numba can be used to very easily work with multiple processor cores. But my suggestion would be, even though lists are allowed, please stick to NumPy arrays if lists are not absolutely required for your problem. NumPy arrays are much faster. Okay.
Thank you, sir.
Yeah. One more library I forgot you should also look at is SciPy. This one of the contributors of SciPy is a professor from aerospace department in IIT Bombay, right? And SciPy is even better tool. Even not a better tool, it also has capabilities that NumPy doesn't have. For example, it can take Fourier transforms, it can take Laplace transforms, it can do time integrations, everything, right? If you want to do symbolic mathematics, you can go to SymPy. So SymPy does something like this. So this is a separate software, but let's say if you have a function, I say that f equal to x square, and I want to take derivative of that. You know what is the derivative? 2x. See, it gives 2x. So this is something, if you want to do in Python, you should look at SymPy. These are the SymPy I don't have installed, sorry. But anyway, you can look at SymPy. Someone else asking about this thing before, so you should take a look at this. Yeah, any more questions? You can raise your hand if you want to. No more questions? Anything extra you wanted to learn that I could not cover? Some expectations that I could not meet? So the coordinators, right, Gokul and Sneha. So I would request you to circulate feedback form. So last time also, I guess, who was it? Harshil and Vaishnavi, I guess. They also
Yeah, yeah.
circulated a feedback form with the attendees. So I would like an honest feedback from everybody, right? If it is very harsh feedback, that is also fine, right? This is because I am also not a full-time teacher, right? So it is also nice to see, nice to get some opinions from the students, see where I can improve, what you didn't find uh, useful, what you did find useful, right? So that I can also gauge what really undergrads or students want. So that is something I request Neha and Gokul, please share a feedback form with them and the responses with me, right? So I would like to look at the responses.
Okay, sure, we'll
Sure,
do
we will
that.
float the feedback form after the meet.
Yeah, thanks. So I don't know if
Sir?
you guys have any. Yes, go on.
I had a doubt. Can we increase the speed of case function using the number?
Switch case using number, as I said, right? I have not used switch case in 6 years. So best way to get these answers, go to documentation or even Stack Overflow. Does number support? It supports if and else. It can you can have as many if and else's inside, but it is usually very slow. If and else kills the performance. Does number support switch case? Okay. Okay. Yeah, so see, at least Google AI says it does not support. So if you want to do something like switch case, you have to stick to if and else. So as I said, right, switch number was created to speed up Python for people who really need that performance and are willing to give up some of the niceties of Python. That is why number was created, right? And you will find it sometimes difficult to code in number. It will give you very weird errors. It will say, now I am not happy with this, do this. No, I am not happy with that, do that, right? And you have to be patient with it. But if you can write very bland code with number, you can use for loop, you can use while loop, you can use this thing, if else, right? You can also use some sort of a class. Don't use that. I recommend wait at least 2-3 more updates of number to use that. You can do a lot of things here. You see, you can also write codes that you can run on GPU using number, right? So many things are possible using number, but some of the niceties they have taken out because they are simply not worth optimizing. Like switch case is something that it's not worth optimizing. If you are really into switch case, most likely you will not use number. Okay, so what you can do instead, you can use switch case, right? So what you can do is that you have a switch case statement, and inside each of the case you have a more complicated function which is number optimized, right? Understood? I don't know if you are getting what I'm saying. So let's say you have switch, right? And inside you have case 1, case 2, and case 3. And if case 1 is true, then you are calling a function which is number func1, and you are passing some argument args, and you have separately defined number func, which is number func def. It's a function, it takes some args and does something, and it is you have been using the number.ng, right? Similarly, you can have multiple such number functions which are, let's say one of them takes exponential, one of them takes log, one of them does sine, tan, cos, whatever, right? And you have inside these cases you are calling these number functions. That is perfectly fine, right? So these things run in Python. Only these functions are optimized with number. So you can optimize parts of your code using number. It's not that entire code has to be optimized with number. So parts of your code can be optimized with number. For example, look at this code, this moving ellipse code, right? You see these kernels are optimized using number. See, all of them are @numberjit, @numberjit. But this time integration function, this is not numberjit. This runs normally, right? Normal Python. But inside I am calling all these numberjit functions. This update solid velocity, right? Update move ellipse. So that is perfectly fine, right? Because there are some of the things here that I cannot do inside number. Some of the things here that I cannot do inside number. That is why I am doing them outside, but more parts which are more computationally expensive, which take more time, I am putting them inside these number functions and they execute pretty fast, right? If I don't do number.ng, you will already be able to see how much difference it makes in the runtime, right? For the moment, how much time did it take? So it took 2 seconds to run. Now let's see how much time it takes. Oh, see how slow is this? It's already 2 seconds. It is telling that it will take 2 minutes 12 seconds. Get it?
Yes, sir.
Did you see that why number is useful and how can you make use of it, even while retaining most of the things that Python has to offer? So parts of your code which need optimization, you use number. Means parts of your code which requires it to be run fast, very fast, you use number there. Wherever it is not required that it runs really fast, don't use number. You won't gain much. See, it is so slow. And now I will kill the interruption because I don't want to waste 2 minutes on this. And let us go back to number, and you will see that it will be run in 2 seconds. So this was just an attempt to convince you that number really is useful. Right? Done. Already done. Now it's creating the animation. So this is the use of number. And if you are more interested in solving problems like this, please look into number. Look into their documentation. Ask ChatGPT. It will help you with understanding. Don't ask it to write your codes. Instead, ask you to explain the codes that you have written. You write codes and ask it to explain. That is how you will learn that how the code works. Right? So learn number if you are really interested in accelerating the performance. If you are not, okay, for the moment work with NumPy, no issues. Even pure Python also work. Many of the pure Python workflows, right, some web browser or apps that people design will not work with number. They have some functions which are not optimized by number. Number is typically targeted for people who want to do scientific computing. Right? You want to solve PDEs, you can solve ODEs, you want to do solve matrix equations. For them, number is very, very good. Understood?
Yes, sir.
Yeah. Any more questions?
I think that's it from the participant side. If there are any questions, or let's say we'll float the feedback form, we'll ask for the questions as well, and then you can answer them. So thank you so much, Maladeep, for coming and taking so long. Like literally, the participants might have understood very well, and it was so, I mean, from basics to the advanced level. So I think participants must have enjoyed and got to learn from such an experienced person. Thank you so
So
much, and thank you, audience, as well. Yeah, Maladi.
yeah, so I wanted to thank everyone for attending and the coordinators for offering the opportunity. Right. So this is my second time. Last year also I conducted the same workshop on Python. Uh, what I want you to take away from today's session, I will already anyway give you all the notebooks. Right? You can play around. What I just want you to do is that please, if you are interested with Python, try to start learning it yourself. Right? Don't wait that I will watch 80 lectures and become an expert. No, don't get an expert by watching lectures. Right? You get an expert by making mistakes. So please start making mistakes as soon as possible. Right? That is my thought at the end, and I wish everyone all the best, and hopefully you guys become an expert in Python. Thank you.
Yeah, I think Maladi, you said it very rightly, because I feel that whichever branch you belong to, like the coding is the very essential part as of the today's world is concerned. So whatever you guys gonna do, you should like know the basics of the coding, and especially Python is very important, specifically in the chemical engineering. So I hope you guys got the gist of it, and I hope you guys will learn it further by yourselves. We'll share the feedback form. I hope you'll fill it and give the true responses from your side. Yeah, saying it, thank you so much, Maladeep, and also all the participants for attending for so long and being here consistently. Thank you.
Thank you. Bye.
Yeah, everyone, you can leave the meeting. We'll share the recording soon, and we'll share the Python files also with you.
Like if you have any other queries regarding the meeting, how the recordings will be shared, certificates, anything, you can ask in the group. Thank you.